Hello, today I'll be going over LeetCode number 62, unique paths. So the problem statement is that a robot is located at the top left corner of an m by n grid and is marked as start in the diagram. And the robot can either move only down or right at any point in time. And the robot is trying to reach the bottom right corner, which is the finish line. So for example, we have the robot at the top left corner and it can move either right or it can move down. And the robot is trying to go to the finish line. So what we want to do is print out the amount of ways the robot can go from start to the finish line. The main solution to this problem involves strategy. And the way we think about this is, how many ways are there to get from S to S? There are 0 ways, because we already start out at the position S. How many ways are there to get from S to this square, the square directly to the right? There is one way to get there, and that is by moving to the right once. How many ways is there to get to the square 2 spots away from S? There is one way. You can move 2 spots to the right. Similarly, for these squares, you can move 3, 4, 5, or 6 spots to the right. So therefore, for example, there's only one way to get from S to this square over here, and that is to go to the right by 6 spaces. Similarly, we will notice that to go down, the amount of ways to go down 1 square is 1 way. For going down 2 squares, it is simply just going down, directly down 2 squares. We cannot go right in this example. So now the question becomes, how many ways is there to get to this diagonal square from S? There are 2 ways to get here. You can go right, then down, or we can go down, then right. And what we notice is that this number 2 is composed of the amount of ways to get to the square above it, the amount of ways to get to the square to the left of it. And if we look at the next one, how many ways are there to get to, for example, this square here? There are 3 ways. You could go all the way to the right and then go down 1. You could go right, down, right again, or you can go down and all the way to the right. And what you notice is that this 3 is just 1 plus 2. So what we notice is that if we fill out the table using this, so for example, the next square here will be 1 plus 3, 4. And what this is once we get to this square, you notice that the answer is 28, which means that there are 28 ways to get to the square E, which is our answer. And the way that this works, or why this works, is because suppose we're at this square, and we want to figure out the amount of ways to get to the square to the right of it. The way we do this is, if we calculate the amount of ways to get from here to here, we notice that we can just go down once and go to our square. So if there are 5 ways to get to the square above it, then there should be 5 ways to get to this square as well. Now, for the square to the left of it, if there are 10 ways to get to that square, then there should be an additional 10 ways to get to the square to the right of it. Because in each of the patterns, once we get to this square, we can just move to the right once and get to the square which we want. So that is why each square, the amount of ways to get to 1 square, is the amount of ways to get to the square above it, plus the amount of ways to get to the square to the left of it. So in our solution, we first created an array where we started storing the values. So let's create that array. So in that array, now we have to traverse through the array and fill in the values for each square. So let's write out a double nested for loop. Now inside this for loop, we're going to have 2 conditions. We notice that on the top, in the entire top row, every single square had a value of 1, meaning that there is 1 way to get from start to that square. And same for all of the squares on the left-hand column, all the squares had a value of 1, meaning that there is 1 way to get from start to those squares. So we can write an if statement for this. We can write if I is equal to 0 or j is equal to 0. then we're going to fill in that value as 1, because there's one way to get to that square. If not, then we're going to fill in the value of the square we're at as the value of the square above it, plus the value of the square to the left of it. And then at the end, what we have to do is, at the finish line, we have to return the value of that square. So given n and m, and using 0 indexing, we'll notice that we have to return the value of r at position m-1, n-1. If we submit this to the testing website, we see that it is successful.